This is section 3, water as an acid and a base. A amphoteric substance is a substance that can behave as an acid or a base. There are a few substances that can actually do both, and water is actually one of those substances that can do both, meaning it can act as an acid or a base. And so we just give it that special name. The ionization of water, the transfer of a proton from water to one molecule to another to make that hydronium ion, and I'm showing you that equation right here, where you have two water molecules and basically you're transferring protons from one to another, and you get that hydronium ion in an OH. Basically what happens is the concentrations of both of those waters, of course we have a neutral concentration. You have a concentration of 1 times 10 to the negative 7th molarity at room temperature, which is 25 degrees Celsius. And so these concentrations are abbreviated. We abbreviate concentration with brackets and a C. And so what happens is that the concentration then of the hydronium ion and the concentration of the OH ion, which I'm showing right up here, if we take those two and multiply them together for water, is 1 times 10 to the negative 14th, and that's really helpful. We call that actually kW, and kW is the ion product constant of water. It's very helpful. It allows for us to actually, since it's derived from the hydronium ion and the OH ion, we can actually use that to figure out, as to show down here, we can use that as a constant to figure out hydrogen ion concentration or OH ion concentration. And so we're going to actually do that. It also allows for us to determine other things. Like, for example, if in a solution, if the hydrogen ion concentration is greater than the OH ion concentration, it's acidic. If the hydrogen ion concentration is less than the OH concentration, the solution is basic. If the two concentrations are completely equal, then we say that the solution is neutral. The greater the OH or OH, the more acidic or basic then the solution is. So whatever that concentration is determines its acidity or basicity of that particular solution. Alright, some examples here. Alright. We're going to work through how to find the concentration of one of these particular ions given, sorry, ignore that, apologize. Okay, need a pen anyway. So we're going to calculate the concentration given something else. So, like, for example, they want to calculate the hydrogen ion concentration or the OH concentration required for each of the following solutions and state whether the solution is neutral, acidic, or basic. Okay, so they gave us for the first example here, they gave us 1 times 10 to the negative 5th molar OH. And so we have our equation that kW is equal to the concentration of H plus times OH minus. Alright? And we know that kW, though, is 1.0 times 10 to the negative 14th. Well, they've given us, in this first example, they've given us the OH concentration. So we can fill that in. We know that this is 1.0 times 10 to the negative 5th. So basically this is a division problem. And I can solve for H+. The concentration of H+ is, take these two numbers and divide them out. And so I would use my calculator and I'd figure out that that's 1.0 times 10 to the negative 9th. Or you could use your rules of exponents too, right? Negative 14 minus negative 5 is negative 9. And 1 divided by 1 is just 1. Okay? And of course you'd still use sig figs too, right? 2 and 2 still be 2. Alright? And so the other thing is that the question is asking, is this acidic, basic, or neutral? And so again, I would look at this and I'd say, okay, compare the H+ to the OH. In this case, this is 1.0 times 10 to the negative 9th. This is 1.0 times 10 to the negative 5th. Which one is bigger? Well, remember, negative numbers, the one that is, least negative, so this one is least negative, whichever one's closer to 0 is the bigger number. So this is, the OH is bigger, so this is a basic solution. Okay. Alright, let's try the next one. Alright, so they gave us in this one, they gave us 1 times 10 to the negative 7th molar of OH. Alright, so we know again, and you get to the point where you don't even write the KW, you just say, okay, well I have 1.0 times 10 to the negative 14th, that's equal to the hydrogen ion concentration times the OH ion concentration. In this case, I have the OH again, just like the last one. Sorry, I should put the negative there. I don't know why I put there. And so I have again 1.0 times 10 to the negative 7th. So I'm going to divide each side by 1.0 times 10 to the negative 7th. 1.0 times 10 to the negative 7th. Again, calculator, rules of exponents, whatever you choose to do mathematically, you still get 1.0 times 10 to the negative 7th. And again, these are all molarities, so I guess I should label. I don't think I labeled the last one. And so that is the H+ concentration. And so, again, compare your H+ to your OH. In this case, they're both 1 times 10 to the negative 7th, right? So they're equal. So this is a neutral solution. Okay. Alright, and last but not least, now this one's a little different because there's not even any exponents, this one, and they're giving us the H+ concentration. We have it, so two different ones. So again, though, I have 1.0 times 10 to the negative 14th, that's equal to my H+ times my OH. Okay, and then, so 1.0 times 10 to the negative 14th, that's equal to, this case, 10 times my OH. I'm going to divide each side by 10. So this might be one that you plug in your calculator instead of course, just looking at, because you don't have any exponents in this case. So this one I work out to be 1.0 times 10 to the negative 15th when I calculate it out for my OH concentration. And hopefully just by looking at it, you know that the number 10 is a lot bigger than 10 to the negative 15th. So hopefully you see that when you write this out, that your hydrogen ion concentration is much larger than your OH, so that you can determine that this solution is acidic. Okay, so that's what you want to work through with these kinds of problems. You're just going to be using this equation and doing those kinds of things.